So today's video is going to focus on dihybrid Punnett squares and how to solve them. And we're going to show you a couple of different ways to solve them, and we'll go through a few examples. It would be beneficial for you to have your notes template open. Either go ahead and split your screen so you can see the video and have your template open, or maybe just turn the video on your phone, and so you have the template open on your device. But that template has the examples already built into it and gives you spaces to go ahead and fill in that template so you have worked examples. Dihybrids are the same as a monohybrid Punnett square in the sense that you're going to pull out your gametes and then you're going to find your combinations of your offspring. So let's look at the different ways that we can do this. So up here at the top here, we have this table here that has these different traits of these plants. And so let's look at our problem. Our problem here tells me that I have a heterozygous. Remember, heterozygous means two different. So it's heterozygous tall. So I've got one plant that is big T, little t, with white flowers. So it's describing the height of the plant as well as the look of the flowers. You'll see flowers are recessive. White flowers here are recessive. So this plant is heterozygous for tall, and it is homozygous recessive because it looks recessive. It has white flowers. It's crossed with a dwarf plant. So that dwarf plant is recessive. So little t, that is homozygous dominant for purple flowers. So big P, big P. So there's my two plants that I'm crossing here. And the question is asking me what percentage of the plants will be tall with purple flowers. And so, like I said, there's a couple of different ways that we can solve this. So all the boxes on here outlined in red, those are text boxes that you should be able to click on and type in so you can go ahead and kind of work with me here. So I'm going to show you two different ways to do this. I will tell you, I prefer the second method with the two squares, but I will give you both options so that you can see them. So the first thing that we need to keep in mind when we work over here on the left with this big, large Punnett square, so over here on the left side with this big 16-box Punnett square. So when I'm doing that, I'm going to take one plant. So let's take this original plant here, and I'm going to keep it on one side, and I'm going to take the other plant, and I'm going to keep it on the other side. So the homozygous recessive and dominant. So I'm going to take one plant, I'm going to keep the two plants together. And what I need to realize is that when I do a Punnett square, right, on the edges of my Punnett square, those are my gametes. Those are the possible things that the parent can pass on. And remember, the parent can only pass on one of each trait. So for example, they could pass on the big T and a little p. They could pass on the big T and the other little p. They could pass on the little t and a little p, or they could pass on another little t and a little p. Never will they pass on both t's or both p's, right? That would be a mutation. They pass on one of each. So I'm going to do the same thing with this other parent on the other side, right? They have a little t, big P that they could pass on. They could also pass on this little t with the second big P. They can pass on their second little t with the first big P, or they could pass on that second little t with the second big P. So you notice I kept both the parents together, and I made sure I gave one of each. And remember, these here, these are the gametes, right? That's what the parents can pass on. And so now I just combine these like I would in like a monohybrid Punnett square. But I'm going to combine the two T's and then the two P's and then the two T's and the two P's, two T's and the P's. So I'm just going to go through and I'm going to combine all of these until I have completed all 16 squares. And once I have completed all 16 squares, I can then go back and use these completed squares to answer my question. So my question says, what percentage of plants will be tall with purple flowers? So based off of this information, the ones that will be, remember, tall is dominant and purple is dominant. So this one will look, this one looks dominant for both, 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 dominant for both. And I just go back and count. 1, 2, 3, 4, 5, 6, 7, 8. So now I get 8 out of 16, which when I answer in a percentage, that's going to be 50%. So that's one way you can do it. The drawback to this way is you have to make sure you can find the gametes and put them on the edges, and then make sure when you're going back and you're counting that you don't miss any. So let's take a look at the other way to do this. So the other way to do this is to do 2 Punnett squares, 2 small Punnett squares. And if I do 2 small Punnett squares, then I'm going to treat this like I'm going to separate the 2 traits out. So I had one plant that was heterozygous tall crossed with a short plant. And then I had one plant that had white flowers crossed with homozygous dominant purple flowers. And then I'm going to go ahead and I'm going to complete that just like I would a regular monohybrid. Big T, little t on one side, little t on the other side. Go ahead and do my combinations inside. And then let's see, little p, big P, and go ahead and do my combinations. So this one is a little bit different in that sense. So in this case, I take the 2 traits and I split them up. You'll notice I didn't mix any T's and P's together yet. And when I do this, when I do it this way, I now need to bring in my rules of probability. So I'm focused on tall first. It said they were going to be tall. So when I look at this first Punnett square here that involves height, 2 out of 4 look tall. And then the second one, the second trait, purple, when I look at this second square here with them being purple, 4 out of 4 look purple. I want these 2 things to happen at the same time. This is an and situation. I want the plant to be tall and look purple. So when I want 2 things to happen at the same time, I multiply them. So now when I multiply this, I get 8 over 16, which again is 50%. So I get the same answer either way. You will not be forced to solve it one way or the other. If you saw the giant Punnett square and you kind of freaked out, the only thing you would be required to do with the giant Punnett square is possibly read an already completed one. But if you're being asked to solve your own problem, you will not be required to do it one way or the other. You can choose whichever way you prefer. So we're going to look at one more example with this. Okay, so I've got plants again. This time I have a plant that is yellow, so that's little g, with wrinkled seed pods. Wrinkled is recessive, so little s. And then it's mixed with a hybrid. Remember, hybrid is heterozygous. So a hybrid for pod color, so big G, little g, and for shape, so big S, little s. So if I'm going to do the large Punnett square, remember I keep one parent on one side. So I go ahead and I do all my possible gamete combinations, right? Little g, little s, little g, little s, all my options for that. And then I put the other parent on the other side. I could have a big G with a big S, big G with a little s, little g with a big S, little g with a little s. And then I go ahead and I complete everything inside the square. Okay, I'm not going to waste all your time writing all of this in. It's because it's a little bit tedious. You get the idea. You also, if you're super comfortable with this and this is the way that you want to do it, you'll notice they're going to be exactly the same all the way across. They're going to be the same all the way across. The same all the way across. Okay, if I'm doing it the other way, right, and I'm using the 2 small Punnett squares, then I separate out the 2 traits, right? I do a trait for color and I do a trait, a Punnett square for shape. So I go ahead and I complete those Punnett squares. So I put my gametes on the outside, and then I go ahead and I complete it just like I would a regular monohybrid. Trying to really exaggerate that those S's are big S's, so there's no confusion. And again, now I want percentage of offspring that will look dominant for both traits, meaning they have to have at least one big G. So 2 out of 4 will look dominant for color, and at least one big S. So again, 2 out of 4 will look dominant for shape. I want these two things to happen at the same time, so I multiply them. 2 times 2 is 4. 4 times 4 is 16. Again, it wants percentage, so percentage-wise, 4/16 is 25%. If I come back to my large Punnett square, right, only this top row here looks dominant for both. This only looks dominant for the first trait. This only looks dominant for the second trait, and they look dominant for neither one on the bottom. So again, 1, 2, 3, 4 out of 16 gives me 25%. The other thing that you will need to do is to be able to do phenotypic ratio for dihybrids, not genotypic ratio. We did that for monohybrids when we had the various genotypes and we counted how many we had of each one. Okay, this is only phenotypic ratio. And when we calculate phenotypic ratio using this, we're counting how many will look dominant for both. Dominant for the first, recessive for the second, recessive dominant, recessive for both. So we're just counting what they look like. So in this instance here, I have a dwarf plant, so it looks recessive with yellow seed pods, so looks recessive all the way, mixed with a plant that's hybrid for both height and pod color. So they're going to be hybrid for both of these things like this. So again, I'm going to keep one parent on one side. So I find my gametes, big T, big G, big T, little g, little t, big G. We do need to understand that the gametes are what the parents are passing on. They form from meiosis, right? And they have one copy of each allele. I keep the other parent on the other side, right? The other parent was my little t was my recessive for both parents. And so my only combination of possible gametes here is little t, little g. So again, when I make these combinations, they're going to look the same all the way down. It's going to repeat all the way down. Again, it will repeat and it will repeat. If I do it the other way with the 2, remember I keep the traits separate here. So I take my height trait and I make a Punnett square for height trait. And I take a Punnett square for color trait. So I use my same things. I'm looking dominant for both. So in this case, I've got 2 out of 4 look dominant. 2 out of 4 look dominant for seed color. I multiply those things because I want them to happen at the same time. So 4 out of 16. If I come over to this other Punnett square and count this column right here, 4 out of 16 look dominant for both. Okay, my next number, dominant and recessive. So 2 out of 4. 2 out of 4 look dominant. And then 2 out of 4 look recessive. So 4 out of 16. So again, 4. Recessive dominant, same thing. 2 out of 4. 2 out of 4. So again, I'm at 4 out of 16. And my final one has to be 4. I have to add up to 16, right? 2 out of 4 look recessive for height. 2 out of 4 look recessive for color. I want the two things to happen at the same time, so I multiply, and I get 4 out of 16. Okay, so, and if I did the large one, I would just count, right? Dominant, recessive, 1, 2, 3, 4. Recessive, dominant, 1, 2, 3, 4. And then recessive, recessive, 1, 2, 3, 4. So that's how you would solve phenotypic ratio for a dihybrid. Okay, so we'll do one more. So this one is going to be a little bit special. So for this one, I'm heterozygous for tall and for purple flowers. And it's bred with a hybrid. Remember, hybrid means heterozygous. So a hybrid tall and purple. So in this case, both plants are heterozygous for both traits. Where this becomes important is this is going to be the most common one you're going to see for phenotypic ratio. Okay, this is the most common one you will see for phenotypic ratio. And so ideally, we're going to go ahead and we will memorize what this is. All right, so let's practice calculating it real quick. So remember, when I calculate it, I count how many look dominant for both. That's my first number. So in the first square, I have 3 out of 4 look dominant, and 3 out of 4 look dominant for flower color. So I get 9 out of 16. So that's my first number for phenotypic ratio, 9. Then it's how many look dominant for height. So for the first trait, so 3 out of 4. And how many look recessive for the second trait. So 1 out of 4. So 3 times 1 is 3, and 4 times 4 is 16. So I've got 3 out of 16. My next number is how many look recessive for the first trait. So 1 out of 4. And then dominant for the second trait. So again, my number is 3. And then my last number, right, is how many recessive for both. So 1 out of 4, 1 out of 4, 1 out of 16. 9,331 is your most common dihybrid phenotypic ratio. So if it tells you that if you're doing a heterozygous for both traits cross, both organisms, both traits, everything is heterozygous, 9,331. You don't need to solve it. You just need to memorize that. Okay, so that's our skills with dihybrid. We need to be able to solve them. We need to be able to calculate phenotypic ratio from them. So we will practice these in class.